Hey there, pre-calc friends. Let's take a look at this review packet here for our section 4.3 quiz that's coming up this week. So it's only on one single section, and this review packet's pretty good because it has a good mix of all different types of problems and concepts that you need to know. And we have all of the answers on the back few pages as well, so you can double check. I'm actually going to go a little bit out of order because I want to go in the order of the way that we learned everything. So in fact, the first topic we learned was on review 2, number 1. This was the first kind of question that we learned. And then what I'll do is I'll show you other places in the review packet that are very similar to that one. So in case you want to do more repetition before going on to each new concept, you can do those similar types of problems and then move on to the next type of topic. So I'm going to start with review number 2, question number 1. This one says the terminal side of an angle theta is in standard position. Don't remember what that means. And it passes through this xy point negative 2 comma 4. Knowing that, can we find the value of all 6 trig functions of theta? All right, first of all, let's translate. That's a lot of words here, folks. So what that means is, when we first talked about trigonometry in section 4.1, we said that when we put an angle in standard position, like we said here, standard position, what that means is we stapled one end of it right there on the x-axis going east. And that one stays there. The terminal side is the one that spins around all the way around, and wherever it stops, right there, for example, that's your terminal ray. And that determines all the different types of triangles and angles and quadrants. So there's a lot of words here, but it basically means things that you already know. It just means if we have an angle or a triangle and it's going through this point here, can we use it to find the value of all 6 trig functions? All right, let's give it a shot. So the first thing we should do is, well, let's graph the point negative 2 comma 4 and see what we can get. Negative 2 comma 4 is going to be in quadrant 2 because the x is negative and the y is positive. So I'm going to move to the left 2 and up 1, and I get this point right about there. There is negative 2 comma 4. We connected that from 0, 0 to that point, just like there. And what we actually just formed is the terminal ray, or the terminal side. It turns out to be the hypotenuse of this triangle that we're going to make. Speaking of which, we need to make a triangle. So we always go to the x-axis to make our perpendicular side. We never go to the y-axis, we always go to the x-axis. So there it is. And the theta angle is always right inside here. Here is theta right there. It's on the inside. So if I was to blow up that triangle a little bit bigger, theta would be right here. It's always the one next to 0, 0. All right, once we have our triangle, we can label the length of these sides. Now that we knew that it was negative 2, 4, that means the bottom length is 2, but because it's going to the left, it's a negative, and the purple side on the left is 4 because we drew the point negative 2 comma 4. So those two sides make sense. Now, in order to find out the hypotenuse, we're going to have to use our friend Pythagorean. So here we go. A squared plus b squared equals c squared. All right, well, we're given a and b, and we have negative 2 squared plus 4 squared equals c squared. Folks, notice that I put the sides in parentheses. It's very tempting to just square negative 2 and then you accidentally get negative 4. But remember, when we square these, we always get positive numbers out. So I'm using parentheses just to remind myself that I'm always going to get positives out. All right, negative 2 squared is positive 4. 4 squared is 16, which gives me 20. And that's c squared. So in order to get c, we're going to take the square root. And c is the square root of 20. But knowing our algebra skills, we have to make sure we reduce that. And that's the same thing as 2 root 5. If you need help figuring out how to go from here to here again, a little algebra review, feel free to go back to our expected knowledge and our algebra assessment problems because they'll help you out with that too. Or come see me extra help and I'd love to teach you again. All right, so that means our hypotenuse over here, right there, is 2 root 5. All right, folks, we're good to go. Let me redraw this triangle again a little bit bigger so you can see it. But basically, here's what we have so far. We have a theta there. We have a negative 2 side on the bottom, a 4 on the left, and now 2 radical 5. So I think we're good to go. Now the question asks for the value of all 6 trigs. That means I need to find sine, cos, tan, and all of the flips. I'm going to make a little bit of room over here so I can make my list. All right, what do we need to find? I need a new color here, Mr. Brown. How about the sine of theta, the cos of theta, the tan of theta, and then all the reciprocals, and I'm going to put that next to it so I don't forget which one relates to which one. The flip of sine is cosecant, the flip of cosine is secant, and the flip of tan is cotangent. All right, so always, always our best friend is SOHCAHTOA. So I'll put that off to the side here. All right, so for our triangle right over here on the left side, we formed so beautifully. Let's do sine, which would be opposite over hypotenuse. That would be 4 over 2 root 5. And remember, we got to clean that up by doing rationalizing, how we multiply by root 5 over root 5. Okay, we've been doing that quite a bit, so I'm going to jump right to the end so you can see what it's going to be. But basically, when you're all done rationalizing everything, the final answer for sine should be 2 root 5 over 5. And there we go. That was opposite over hypotenuse and rationalized. We're going to do the same thing with cosine. Cosine is going to be adjacent over hypotenuse. We're going to rationalize it so beautifully by multiplying by root 5 over root 5, and the final answer should be negative root 5 over 5. The tangent, toe up, opposite, which is 4 over adjacent, which is negative 2. And I can even just straight on divide that. 4 divided by 2 is 2 with the negative, so the answer is negative 2. All right, those are the first 3 trigonometric functions. So now we're going to do the reciprocals and flip them. But if you remember, when we first did, for example, sine, we did sine by doing opposite over hypotenuse. I'd rather flip that one to get cosecant because now I won't have to re-rationalize. So when I flip it, I'll get 2 root 5 over 4. And the 2 and the 4 can reduce a little bit since they're both outside the radical. So my answer there would be root 5 over 2. Same reasoning for secant. If I take the cosine, the original cosine, and I flip it, I will get negative root 5 over 1, I believe, or just negative root 5. The cotangent, if I flip negative 2, which in your brain could be thinking negative 2 over 1, making a little dotted 1 here. If I flip that, I would get 1 over negative 2, or just negative 1 over 2. And that's how that question will go. We're all done. We did it. Great job. So again, what did we do? We graphed the point over here first. We made our triangle here. We labeled the sides according to the x comma y. Watch out for negatives. We used Pythagorean to find the hypotenuse. Cleaned it up a little bit if we need to. And then over here off to the side, we did our whole SOHCAHTOA over here. And that's the answer to number 1. It's a bit of work, and it's a bit of a long problem. So similar ones, if you feel comfortable and you want to do review 4, number 1, that's just like it. And review 6, number 1. So if you want to go in order and again get more repetition before you move on, feel free to pause the video now, go and do those, and we'll come back and do some more problems. All right, the next kind of problem that we can work on would be basically number 2 here. But I think what I'll do is I'll go find another page that's a little bit cleaner. How about this one? This is a great puzzle problem for us. What they're doing is they're going to tell us where the angle lives. They're going to tell us one puzzle piece. Can we use that to then find this? So we'll use the terminal sides in quadrant 4. We'll use the knowledge that the sine at that angle is negative 725. And then try to figure out what is the cosine of theta. All right, first thing to do, why don't we go ahead and graph it? So I'll graph. It says it's in quadrant 4, and I don't know exactly what it looks like in 4. I just know it's in 4, so I'll just graph a random angle in quadrant 4. There we go. All right, in order to do trig, we need a triangle. So this time we're going to go up to the x-axis, but it's always the x-axis. Always, always. There's our right angle. And theta is always nearest to the origin. There we go. All right, we got our triangle. Now, let's do this purple part over here. If we know that sine is the opposite of hypotenuse, and I get 7 over 25 and some negative somewhere, can we put those sides here in the triangle? Well, again, looks like the opposite would be 7 and the hypotenuse would be 25. So relative to this angle theta, there's your opposite across the way. So 7 would be here, hypotenuse would be here, which is 25. But now where's the negative? Well, because this side is going down on the right side, the 7 would be the negative, because down is overall a negative movement, negative 1 perhaps. All right, well, here comes Pythagorean again. In order to find this side over here, when we use Pythagorean, this is actually a really nice number, ends up being 24. This is a 7, 24, 25 triangle. Now, because it's going to the right, this is a positive 24, so we can leave it as just 24. All right, so we graphed it in quadrant 4. We put in all of our sides based on that given puzzle piece, and now all we got to do is just solve the problem. Ready? Cosine is so ca. So I need the adjacent over hypotenuse. And in our triangle, we have adjacent, we have hypotenuse. The answer here, folks, is 24 over 25, and you're done. It's a fun problem. Again, try to graph the triangle in the right quadrant. Use the little puzzle pieces to figure out the sides and use Pythagorean to help if you need to. And then try to figure out what trig are they looking for. How could this be a little bit harder? Well, in some problems, the thing that I give you, for example, this is on review 2, number 2, what if I give you the cosecant? That's kind of hard to figure out how to put that on the triangle, so I would flip it to its relative friend, the sine, and say, well, if the cosecant is 2 over root 3, the sine would be root 3 over 2. And that I can put on the triangle because that's opposite over hypotenuse. Also in this one, it's a little spicy because you can see I'm asking for the cotangent. So maybe you should find the tangent, the TOA first, and then go backwards and find the reciprocal. So question number 2 on review 2 is a great one just like it. We just did question 2 on number 4, and I believe question 2 on number 6. They're all really good ones just like that. Sounds good? All right. Then we moved on and we tried to figure out where are trigs positive or negative. And we learned this great chart, and you should write this on the back of your quiz as soon as you get it. These letters tell you which trig functions are positive in each quadrant. The A in quadrant 1 means all of them. Sine, cos, tangent, cosecant, secant, cotangent. They're all positive. There's nothing negative in the first quadrant. Over here in the second quadrant, the S means sine, and therefore its reciprocal cosecant are both positive. That means everything else is negative. Cosine, tan, all that jazz. Down here in the third quadrant, the tan is positive, and therefore the cotan. And again, that means sine, cosine, everything else is negative. And over here, back in the fourth quadrant, the C is for cosine, because cosine is positive, and therefore the secant. And that means, again, sine, tangent, all the other ones are negative. So draw this on your quiz, and you will be good to go. Because now, let's answer number 1. Which quadrant are both of these true? Where is both the sine positive and the tangent negative? Here's what I like to do, and I think I showed this in class a couple times. I'll take one at a time, and I'll put little check marks. Let me do this first one here. Where, in which 2 quadrants is tan negative? Meaning not positive. And I know tangent is positive in T, because it's T, and in A, because they're all there. So where's it negative? Well, it must be in quadrant 2 and quadrant 4. All right, and then I'll come over here and I'll do where's sine positive. And sine will be positive, obviously in the S, because that's sine, and the A, because that's all. So the top 2. Now, can you see which quadrant got the most check marks? And that's the one that wins. So in which quadrant are both tan negative and sine positive would be quadrant 2. Great question. Where else do we have that? Review 3, number 1 has it. Sneaky, because they're giving you secant. But remember, you can change the secant back to the cosine, and if one is positive, the other one's positive too. Cosecant, maybe think of that instead as sine. So once you see that, rethink it as cosine and sine, and you'll be good to go. I believe review 5, number 1 has the same thing. There we go. So some good questions on what trig functions and what trig values are positive in which quadrants. And then we started doing all of these problems. These are the meat and potatoes of all of trig, TBH, because we're trying to figure out the sine, cosine, tangent, all the values of every single angle on our unit circle. Some of these land on the quadrantal angles, the x and y axis. So we'll have to face those in just a sec. But let's just start. This is without a calculator, so you're using a blank unit circle that I'll give you. You can fill in as much as you want, but basically using triangles or quadrantal angles to solve these. Let's take number 2. Part A. I want to know the sine of 90. For all of these folks, first step, go ahead and graph the angle to figure out where we are. And the sine of 90 is right up here, right here. There's 90. Well, guess what? We're right away on the actual quadrantal angle. We're on the axis. Remember, we learned that we cannot do a triangle here. There's no way I can draw any kind of like triangle or anything like that. It's just not legal. So we learned the best thing to do is to remember these 4 points. This is another thing that you should draw on your quiz when you get it. These were all 1 unit away from 0, 0. On the far east over there, we have 1, 0, which means on the west we have -1, 0. Up north we have 0, 1, and down south we have 0, -1. The important thing about this is that the x's are the cosine values. Think alphabetical. X comes before y, cosine comes before sine, and the y values are the sine values. So if you ever graph an angle and you land on an actual axis, just think of the point that's there, the xy point. X is cos, y is sine, and we also learned that the tangent is the y divided by the x. All right, let's give it a shot. So, quick review there. Good. We're at 90, which was up here. I'm asking for the sine. We just said the sine is the y value. Well, what's the y value at 90? It's 1. And that's it. That's all we had to do. So when you land on an axis, remember those 4 points and you are home free. Part B, how about the cosine of 240? All right, like before, let's graph it. I don't think this is going to land on an axis, so we're going to have to go through all the steps. This is a good one to start with. All right, 240 lands you over here in the third quadrant. That's 240. And first step, after you graph it, let's make our triangle always to the x-axis, folks. Always, always to the x-axis. And normally we would draw a little theta here next to the origin, but now we actually know what that angle is. This is our reference angle. So think about what is your reference angle for 240. And after going past 180, in order to make 240, I had to go another 60. So this is going to be a 60-degree reference angle, which means that that's 60. Then over here, we have 30. Great, it's a 30, 60, 90 triangle. Remember your sides? Here we go. Opposite of the 30, up here on top, is a 1. The hypotenuse is always 2. And the leftover side across from the 60-degree angle is root 3. Please be careful, folks. Negatives are so important here. The 1 is going to the left, that's negative. The root 3 is going down, and that's negative. And the hypotenuse is always positive. Always, always. All right, good. We're set up to go. Now let's finish the problem. Let's find SOH CA. What's the cosine? And we're going to use our reference angle as our theta. That would be adjacent, which is -1, over our hypotenuse, which is 2. The answer is -1/2. So look at those steps one more time. We graphed the angle. We made a triangle. We figured out a reference angle. And it's always going to be one of our 2 special right triangles, either the 30, 60, 90 or the 45, 45. We put in all of our sides. We watched out for negatives. And then we solved the problem. There we go. A couple of steps, but really, really important problems. Let's find some more that are really good. How about 3A on, I believe this is review 2. Yes, it is. All right, what's the cosine of theta? I'm going to graph it over here on the left. Theta, if you remember, is 180 degrees. Oh, there we go. I'm on the axis again. What did Mr. Brown say? Oh, that point, right? Okay. So how about -1, 0 is this xy point? I'm going to try and do cosine. Cosine was the x value, right? Well, at pi, or 180, what's the x value? -1. What's the cos value? -1. Done. There we go. Tangent's a good one. I'll let you sort of try that one on your own if you like. That's a good one to try with TOA in the third quadrant, 30, 60, 90 triangle. Should we try some more? How about, this is review 3, number 2A. Tangent of 270. Remember, negative means we're not going to go counterclockwise anymore. Nope, negative means we start east and we go clockwise now. Now, if I'm going to go negative 270, I'm going to be going negative 90, 180, 270 right there. All right, so negative 270 is basically right there. Hey, we're on the axis. Mr. Brown said, remember that point up there, and that's 0, 1. Now, tangent we figured out was the y-coordinate over the x-coordinate. So let's take a look. That means this is going to be y over x, which is our tan. Ooh, 0 on the bottom. Ooh, we don't like that. We can never divide by 0. So we say that is undefined. 0 on the bottom is bad. 0 on top is okay. That's equal to 0, but 0 on the bottom is bad. So the tangent of negative 270 is undefined. We can't find it because we divided by 0. Let's find another good juicy one. Let's see. Ooh, I like this one down here, the secant of 135. Okay, so I'll try that one. I need to make a little bit of space here. But now on review 4, 3b. All right, make a little space over here. Let's find the secant of 135. All right, first step, let's draw a triangle. Draw an angle, I mean. 135 leads you right over here in the second quadrant, right in the middle. There's 135. Make your triangle. This is down to the x-axis. Reference angle. This is 45 degrees, which means this is also 45 degrees. Oh, that's great. It's a 45, 45, 90 triangle. Great. All right, got your sides. That's 1, 1, root 2. Anything negative? The bottom one, because it's going to the left. That's negative. The one on the left side is going up, so that's actually a positive one. And of course, you're going to say the hypotenuse is always positive. Proud of you. So here we go. Let's find the secant. Secant is related to cosine. And the cosine is adjacent over hypotenuse, and we'll flip that in just a sec. All right, I'm just not feeling good about how I wrote the word cosine. How about adjacent over hypotenuse, Mr. Brown? Beautiful. All right, in our triangle here, remember we used the reference angle as our theta. So the adjacent would be the negative 1. Hypotenuse would be root 2. To find the secant, why don't we flip it? And I get root 2 over negative 1, which is just negative root 2. And that's the answer for 3b. What else? Oh, these all look really good. How about 2a? This is review 5, number 2a. Pi over 2. Okay, pi over 2 is 90 degrees. Here we go. And again, we're on the axis. So remember your point, 0, 1. Now secant. Secant again was related to cosine, right? Okay. And we learned that cosine is the x-coordinate. So let's see. If we want to find the cosine first, what's the cosine at pi over 2? What's the cosine at 90? It's the x-coordinate, which is 0. So therefore, what is the secant? Let's flip that. You're going to take 0 over 1 and flip it to 1 over 0. Uh-oh, not good. Remember what we said? This is undefined when you divide by 0. So the secant of 90, or the secant of pi over 2, is 1 over 0, or undefined. Don't be surprised if you see some undefineds on the quiz. That's absolutely fine. How about we pick one more? Let's do here, how about 3b on review 6? All right, I want to find the cosecant of negative 4 pi over 3. Cosecant, is related to sine. So why don't we find the sine first, and then we'll flip it, find the reciprocal to get the cosecant. All right, ready to graph? 4 pi over 3 negative. So we're going to go this direction. And we end up right about here. Here's negative 4 pi over 3. If you need to change that into degrees first, that's fine. It's going to be basically negative 240. So you graph it, and here we go, down to the x-axis. Let's find our reference angle. Our reference angle over here, if this was actually 240, we actually went past an additional 60. So this is a 60-degree reference angle, which means up here, again, we have 30 as a 30, 60, and 90. We get our sides, and our sides here would be, crossing the 30 would be a 1. Hypotenuse is 2. Left over across in the 60 is 3, root 3. Anything negative? Yep, the 1 is because it's going to the left. The root 3 is positive because it's going up. All right, I think we're good to go. So why don't we find the sine first, and then we'll flip it over. Sine, have an opposite over hypotenuse. And here we get opposite from the reference angle 60 would be root 3 over 2. Great, which means now to find the cosecant, we flip that, 2 over root 3. We'll clean it up and rationalize, and we get 2 root 3 over 3. And that is the cosecant of negative 4 pi over 3. And that's generally how these review sheets go. You see a lot of them are very similar. So if you need more repetition, try to do the problems that are all the same types first. When you'll feel comfortable, then move on to the next section and try those. And then to get one more really good review, then just go page by page and try to go straight through. Try to go straight through all the problems on one page because it's a good mixture. And then go to the next page and try to go straight through those problems again, and so on and so forth. Looking over the homework is always a good option as well. And anything else that Mr. Brown can help you with, you just holler. Good luck with your studying and have a great day.